Today we're going to talk about section 2.1, which is relations. A relation is a mathematical term that means a set of ordered pairs. That's all it is. You can have a set of ordered pairs that's just one ordered pair, or you can have several. So you can have, when we talk about sets, we use these little brackets here. So if we have an ordered pair like this, that's a set of ordered pairs. There's just one of them in there. So this is a relation. You can also draw pictures that are sets. For example, if I have this graph here, this square-looking thing is a relation because it's a set of ordered pairs. It's all those ordered pairs that are represented in this graph. So you can either use a graph or you can list out the ordered pairs. Now let's look at an example here of a relation. If we have this relation, and we have three ordered pairs in it, we can know several things about this relation. So we can know the domain. The domain is the set of x coordinates. So in this case, the domain is 1, 3, and 5. So the domain is the x coordinates. That's also called the independent variable. The first number in the ordered pair of a relation is the independent variable, and we list that out, which are the independent variables, using the domain. Then we can also find the range, and that's the y values. So we've got 5, 7, and -1, and those are the y coordinates. And those are also called the dependent variables. And we'll get more into that in a minute. So the domain is the first coordinates, and the range is the second coordinates. Now, if you have a relation that looks like this, where you have just a line that goes on forever, we can look at this and we can write its domain and range as well. We can write the domain, usually we just put a D, because we're mathematicians, we're lazy, we have to have shorthand for everything. So we have a D for the domain, and we look at this and we say, well, what x values are possible? Well, anything on this graph is possible. Well, this is the real plane, so that means all real numbers are the domain. Remember, this funny looking R means real numbers. So the domain is the set of all real numbers. And the range, we look at that and we say, well, what y values are possible? Well, anything on this graph. And since this is the real plane, we can have all real numbers. Now, if we go back and look at our relation we had a minute ago, there's one other way to write relations. We said we could have a list of ordered pairs, and we could also graph them. So let's see if we can do that. So remember, the first one is the x coordinates. We go over 1 and up 5, 2, 3, 4, 5 for that point, and over 3 and up 7 for that point, and over 5 and down 1. So this picture gives us the relation. Now the other way you can do it is using your domain and range. You can make a circle mapping. So we said the domain of this one was 1, 3, and 5. And we said the range was 5, 7, and -1. So to make a circle mapping, what you do is you draw a circle, and that's your domain. So we write the domain numbers in there. And then we have our range, another circle, and you write your range numbers in there. and then we map from one to the other. Well, in this first ordered pair here, we've got 1 goes to 5, and then here we've got 3 goes to 7, and here we've got 5 goes to -1. So this is a circle mapping of the same relation. So we've got a list of ordered pairs, we've got a picture, and we've got a circle mapping that's possible for each of those. Now, we're going to deal with all kinds of relations, but one of the most important kind of relations that we'll deal with is a function. A function is a relation in which every first coordinate has one and only one second coordinate associated with it. So for example, if we have a relation like this, where we have a list of ordered pairs, we look at this and we know it's a relation because it's a list of ordered pairs, and that's what a relation is. But it's not a function. Well, why is that? Well, look, a relation in which every first coordinate has one and only one second coordinate. So if we look at the first coordinates, see where they're repeated. Well, we've got a 2 here, and a 2 here, and a 2 here, which means 2, it's got a 3 associated with it, an 8, and a 1 associated with it. So that is not one and only one second coordinate. Now, what if we have this relation? Okay, this one is a function because we don't repeat our first value. Now, we do the second one, but that doesn't matter. For a function, all we're looking at is, does that first one repeat? Now, there's a way to look at this in pictures and tell if something is a function or not, and that's called the vertical line test. For example, if we have a graph like this, and we want to see if any of these first coordinates, our x coordinates, are repeated, then we can put a vertical line through this and make sure that everywhere we draw our vertical line, we're only crossing the graph one place. So this one is a function because we're only crossing it one place no matter where we draw our vertical line. But here, look at this one. Let's get a different color so we can see it a little easier. If we put the vertical line through here, notice we're crossing the graph in 2 places every time we go through here. So that means that this x coordinate has a y value here and a y value here. So it has 2 second coordinates, 2 y coordinates associated with it. So it is not a function. So a function has to pass the vertical line test. Now, functions can be written as the list of ordered pairs because it's a relation, and it can also be drawn as a graph. But the other way that it can be written is with function notation. Now, function notation is a very useful tool that we will use all the time, and you've probably used a bunch already. You probably just haven't called it that yet. But the way we write it is f of x equals, and then we have whatever formula it takes to get our function. So what this is this tells you what the independent variable is, and this tells you how to calculate the dependent variable. That's why they're called independent and dependent, because you take the independent variable and you plug it in and use that to get the dependent variable. It depends on the independent variable. So if we have, for example, this function here, and we have a domain we're given, which is the list of independent variables, remember, of -5, -3, 2, and 5, and we want to know what the ordered pairs are for that function, then our function is going to be a set of ordered pairs where we have this is our x value, and then our y value is the function evaluated at that, and that's how we write that. And then we have our next x value, our function evaluated there, and our next x value, and then our final one. So here's our function. Well, we can calculate this out. What's -5 times -4? Well, that's 20, plus 6 is 26. So that means this ordered pair is -5, 26. And then this one, we take -3 times -4, which is 12, plus 6, it's 18. And then 2 times -4 is -8, plus 6 is -2. And then finally, 5 times -4, -20, plus 6 is -14. So that's our function right here. We used our domain, our list of independent variables, and put that in our function notation to figure out what the dependent variable values were for each of those and listed out our ordered pairs. Now, I'm going to give you one that I want you to try on your own in your notes. So if I give you the domain is -5, -3, 2, and 5, and then I give you the function is -9x squared plus 12x plus 3. Okay, go ahead and pause it and calculate out what the function is. Alright, so hopefully you finished that and you plugged in each of these values, and you should have gotten -5, -282, -3, -114, 2, -9, and 5, -162. Now if you didn't get those, go back and check. Make sure you're doing this exponent before you're doing the multiplication, that order of operations. Now, sometimes we're going to have a list of ordered pairs and we're going to want our function rule. Now this is a little bit trickier because you have to kind of think sort of randomly almost through things. So what we want to know, if we want to know what our function rule is, we want to know what we have to do to this one to get to that one, because that's what a function rule tells us, right? How do we use our independent variable to get to the dependent variable? So we look at this, and how do I get from -3 to -10? Well, I could subtract 7, right? If I subtract 7, that gets me there. Well, let's look. Does that work from here to here? -1 minus 7 is -8. That does work. And 0 minus 7, that gives me -7. 1 minus 7 gives me -6. So that works perfectly. So our function notation is we take our first variable, our first coordinate, and we subtract 7. And that's all it is. Remember, this is the first coordinate, and this is the second coordinate, which we use this here to calculate. All right, let's try one that's a little bit more complicated. What if we have a list, a function that looks like this? So we have 0 to 2. Well, how can we get from 0 to 2? We can add 2. Okay, that works. So here, if we add 2, that still works. But we run into a problem here. If we add 2 to that one, that doesn't work. So now we need to go back and look. Is there something we could do to this x coordinate, this first one, where we're not changing it if it's 0 or 1, but it might change it and help us if we're doing 2 or 3. Well, if you square 0 or you square 1, you still get 0 or 1. So that's not going to change anything there. So if we try squaring it, so we have 0 squared plus 2, that's still 2, and 1 squared plus 2, that's still 3. Well, let's see if it works at this one. We have x squared plus 2, so 2 squared is 4, plus 2 is 6, so that works. And then we have 3 squared, this is 9, plus 2 is 11, so we found it. So you just have to kind of think through what are the different ways I can go about getting from the first variable to the second one, and that'll give you your function notation. So you need to know the definition of a relation, the definition of a function. You need to know how to write them as lists of ordered pairs, and how to graph them, and how to write them as with their domains and ranges. You need to be able to know what the vertical line test is and how to use that, and how to use function notation, whether it's starting with the domain and the function notation to get the list of ordered pairs, or starting with the ordered pairs to get to the function notation. Make sure you've got good notes, because I'll be checking those in class tomorrow.